everybody. I'm Ryan. I'm co-founder of Coding Nomads, and today I'm here with Sal Mcdonagh. Sal is on the west coast of Ireland, outside of Galway, and Sal has a long, illustrious career, or a number of them across multiple different fields in IT, biotechnology, and most recently data science. And Sal is going to show us some really cool stuff about how to just grab a data set and clean it, modify it, adjust it, and I'm not quite sure, we're going to see, and try to start pulling meaning out of it pretty quickly. I'm super excited. Sal, it's great to have you here.
Great, thanks a lot, Ryan. I really appreciate the opportunity to kind of share a little bit of what I know, and hopefully it's useful to people to get to see how I think. Probably different to, or maybe the same to as most people think, but at least how I go about doing a bit of data analysis when I see a new data set. So
very nice.
Yeah,
very nice.
Great. So shall I share my screen then?
Yeah.
And
let's just go ahead and jump in.
All right. So I think Kaggle's a great place for beginners to start doing data science, and to they've got a bunch of great data sets. So actually, I'll just go to the home screen because I think it's maybe handy for people to see like right from the beginning. It's a little bit slow, I think, because of the screen sharing, but
no problem.
I think you can always, for people that are watching this after, you can always watch it at double speed and then slow it down on the bits if we go too fast anyway. Okay, so if you look at Kaggle, once you've logged in and created an account, which is free, there's this little data menu item here, and there's literally hundreds of data sets. I don't know how many there are in total, but and you can sort them by hottest, most votes, etc. Usability might be a good one for beginners to kind of sort them by and say like, okay, these are the cleanest ones will be up the top. I had a look at a few different ones, but I think I'm going to find one. Let's just see. What's it called? Where our food. I think it's called Where Our Food Goes, or something like that. Who eats our food? Something like that. Yeah, just. Yeah, who eats the food we grow? So this is an interesting data set, right? It's basically the imports and exports of every country in the world. So whenever you look at a data set on Kaggle, they tell you a little bit about it, the context, where the data came from. So originally this is from the FAO stats, so the Food and Agricultural Organization of the United Nations.
Okay.
So it's basically every country in the world, what food they've imported and exported rather. And so this is a little bit of detail about the file, and something just to note here. All right, so in this detail, this is something that when I first had a look at this, I didn't notice, right? So the encoding is Latin for the file. Usually you don't need to worry about what the encoding is of most files, but whoever prepared this put the encoding in Latin. So just a little gotcha, and it tells you even how to read the file in using that.
Yeah, that's nice.
So very, very handy. Also gives you a kind of a little view of the file, a preview, with some some charts, etc., which give you an idea of the total coverage, and the country codes probably not much interest. Food or feed, so whether it's food for humans or feed for animals, the units of measurement. So you can see it's quite an interesting data set. And then it has, so what we'll do is we'll just go and create a new notebook and start from scratch. So you just scroll up to the top, you create a new notebook and choose the language. I'm going to use Python. I'm not going to change anything else. I'll just go click on create.
And now, is this a different, like, is this like a Jupyter notebook?
It's a Jupyter notebook, pretty much, okay. Yeah. So it's I think there's some it's their flavor of Jupyter with some modifications, but it's very straightforward in terms of if you used a Jupyter notebook, you'll have no problem using this. It's exactly the same as you'd expect. You can pretty much do anything. It is a Jupyter notebook underneath. So a few slight differences. Okay, so the first thing here is they import a couple of libraries for you as default, and I think anyone who's used Pandas is very used to seeing this: import NumPy as MP, import Pandas as PD. And I'm just going to leave it at that. So I'm not going to get fancy and import a bunch of extra libraries. We're just going to use the very basics. It also does this import OS, which is the operating system module from Python, and that just allows you to read the local file system. Which I'm guessing is probably Linux underneath here, and it just looks in the local path and shows you what files it is. So I'll just run this cell. You can just click the little blue arrow at the top to run it, or you can click it there, or you can click run up here, and that just gives you a list of the files. So there's only one file in this, so this is a nice easy data set to start with, I thought, and that file is called fao.csv. So first thing I'm going to do is I'm going to read that into a data frame, and the default DF is kind of the
convention. The
convention, yeah, that most people use for a data frame, but you don't have to use it. You could call it whatever you like. So I'm going to say, and then I'm going to use, so we need PD for Pandas and the read CSV. Pandas has a bunch of different read options. So you could, if this was a Excel sheet, you could read Excel. If it was a Python pickle, which is a way of storing not a very space
friendly,
optimized. Exactly. Gobbles up space like nobody's business. Pickles, but you could do a read pickle as well, and you can write data frames back to any of these formats as well. So you'd use anyway, we'll get to that later. So we'll use a read CSV, and I'm going to just copy this whole path into there. I'll just copy that into there, paste, and I'm just going to run this so you see the error message, because this will throw you. And oftentimes when you try and import a data set, you're going to hit something like this where some parameter looks wrong, right? So what if we just scroll up to the very top? You're going to see this. It's a Unicode decode error. So it tells you that the UTF-8 codec can't decode the byte in position 1, whatever, right? So what that's telling you is that by default, read CSV expects this to be in this format, UTF-8. It's just a particular type of encoding, but we remember from the that this is not encoded in UTF. It's encoded in Latin, right? So encoding equals Latin. I think that's
or Latin 1
was. Let's just have a look at so df.head, that just lets us look at the top of it. So
nice.
That seems to look okay to me. I think you're right there. It could have been Latin 1, and maybe Latin 1 is different to Latin. But anyway, we'll go with Latin 1.
Sure.
So we've had a look. We can see it kind of looks right. So we can see that there's area code, and then you see these little dots in the middle here. It means that there's a bunch of fields. Because this has more fields than will fit across the screen, we've ended up with, we've lost some, we can't read all of the fields in here. So a little bit of code, which I'm just going to paste into this here. And all this is kind of some settings to allow you to display more rows, more columns, and to allow kind of a much wider column width. So just do this little df head again. If I run that again, now we can see that we can now see all of the columns, and we can scroll across and see all of our data. Okay, so we can see that this is by country. Got an area abbreviation. I prefer to use the full name if I'm going to use these fields in a pivot table just shortly to start having a look at stuff. The item codes, the item names. So this is the actual produce, and then whether it's food. And we'll have a look, and we want to see what how many categories we have in each of these, and we'll have a look at those in a minute. And then we see that the years are spread this way. So it's got a time series, but it's in a kind of a funny format, right? The time series is running left to right. And most often when you're looking at a time series, you'd usually have the dates going down as your index, maybe.
Right.
Okay, so at any rate, what we'll do is we will, let's just do a df dot hist, right? So what this does is draws histograms of all the numeric columns. So it'll take a little bit of time, and you can see it gives us this nice long line there. Wait for that to finish running. Here we go. So a bit too small to see what's going on there, right? But these are all the histograms for all the numeric fields. So I'll just go and make that a bit bigger. And so we can use the fig size equals, let's just go 20 by 20. So this makes it readable, hopefully readable. Let's see, maybe there's still too much data in there, or maybe there's fields that we don't actually care about seeing, and we can start dropping them and filter down. So it's useful just to have a look at what the data looks like. Okay, so we've got a bunch of histograms. So the area code is probably just a random made up number, right? Element code, don't really care, it's item codes. And for each year, there's just one band of data. So obviously all the data clumps together. And then we have latitude and longitude. So straight off, we can see latitude, it looks like, there's more stuff, probably that's north of the equator, where there's more land mass, than in the southern hemisphere, I'm guessing. You've only got Africa, the bottom of Africa tipping down, and the bottom of South America, which is skinny, and then, and then your longitude, obviously, longitude, the circles get smaller the further away you get from the equator. So, closer to the equator is more, it's a bigger circle, so there's more, you're assuming there's more stuff that hits along that latitude. Okay, so probably not really useful to us, right? Because every year is showing the same distribution here. But anyway, quite often doing that hist will show you something useful about your data, whether it's an exponential decay, that could be a normal curve, normal distribution. And just depending on what your distributions look like, you may want to treat your data. I don't think we have to do anything to treat this data here, because so now we'll just go up and we'll have a look. So we've got all of these. What we want to do is we want to see what our data types are. So df.dtypes. This just tells us what each of these columns, what data type it is. So an object usually is just text, okay? Or it can be numbers that have commas in them and stuff. Area code is an integer in this case. So we see, and we've got a lot of floating point data. So these are all the numbers around the actual values of the tonnage. So if we go back up here, we'll see that our units seem to be all 1,000 tons, but we can validate that. So this is a really useful, let's just have a look at units, and we'll do this as a very useful little function of, what's wrong there? Units doesn't exist, so what's it called? Unit. So if we do value counts, it goes through that column that we've given here. So this little this format basically pulls out of our whole data frame. It just pulls out the unit column and returns it as a series. So it's just got the index and then the values here, and value counts just goes and counts and says, what are the values in there? So we can see it's all in units of 1,000 tons, right? So that's good. So we don't have to worry about, multiplying, getting rid of the text of tons and multiplying stuff to get everything into the same unit. So everything's in the same unit. So that's really handy, but it's something important to check, right? Because when you've got, what does that mean? It means that 1,000 tons, and that also
Right.
means that 1,000 tons, and the same for all countries. So so that's just useful to make sure that we're comparing like with like whenever we do anything.
Like on the third row, for instance, or I guess it's row number 2.
Yeah.
For year 1961, it would be 76,000 tons.
Yeah.
Got it.
Exactly. Yeah. And it seems that for Afghanistan, barley and products, kind of looks fairly static along this. Yeah.
Yeah.
Right. So yeah. So the next thing you want to look at is maybe the element, right? So let's have a look at what the elements, what the value counts for elements are. Right. So I'm just going to go and likewise do that and say element. And we can see there's just 2. There's food and feed. More rows for food than there is for feed, which is maybe what you'd expect, is that there's less types of animal feed than there are of human food, because we don't ask them whether they like extra spices and stuff added to their food quite as much as we treat ourselves to it. Poor old dogs have to do with whatever leftovers there are. Okay, so we've got that, and if we look at item now as the actual, so let's have a look at item. And item is each of the different types of foods that there are.
I mean, even now, like we've just done a couple of quick commands, but it's already pretty, I mean, this data set's great, and it's already really easy to start understanding the global food supply.
Yeah, exactly. You start to get an idea of stuff, right? Now what I want to do is rather than looking at the food values for all items, maybe I just want to look at the feed, right? So let's have a look. What's that column called? It's called element. Element equals feed. So this is a way of, tell you what, we'll do this. Oh, I'll just comment that out. So what this does, right, is it just gives us the data frame, but it selects out all of the rows where element is feed.
Okay.
So you should get that. Maybe not. Maybe element is feed in lowercase or something, is it? Food, yeah, it's lowercase. It isn't all capitals. Okay, so just important to remember, case is important, right? So if we do that, all that does is it gives us a subset of this database with only feed, all right? So if we want to see in what sort of items there are in the feed, we can now see, this is all the stuff that ends up in animal feed. Okay, so there's quite a lot of different items.
Yeah, it looks like they're eating okay.
It does, yeah. So, and let's have a look at food for humans. And presumably there's more in there, right? But we'd need to count them. So let's do our first pivot table, because this is mainly going to be about pivot tables. So let's just do a pivot. So we go pd dot pivot table. And then we have to tell it what the data frame is that we're going to use. And then we're going to say the index is, and let's just use element as our index, because we want to just see by element. And then we want values, and we want to, let's just get a sum of tonnage, right, for all the for a particular year here because I don't want to have to add up all of these years, but let's just have a look at 2013 because that was the most recent year, right? So we'll just say Y 2013. So let's go down and have a look and say Y 2013. And we need an ag function, which in this case, we're going to use sum just to start off with our real absolute easiest version of a pivot table. Okay, so what we've got is our index. So the element is our index there. So it indexes by feed and food. Those are our two different options. The values are year 2013. And this is the total tonnage times 1,000 of this for all the feed and all the food. Okay. And so that's the most basic pivot table.
Mm-hmm.
We can add in an extra year if we want, right? We can say, let's have a look at 2012 and year 2013. You can pass a list, right? So that's just a standard Python list in its square brackets. And now we have both years, right? And you can see that there's been a slight change. What we can also do is we can say margins equals true. So what does margins do? It just adds a total column and row.
Okay.
In this case, it's only a row because feed and food. I don't know why it's not adding a column there. Anyway, it's only adding a row. So we've got a total, and you can see there's a slight difference in the totals there. For some of the tables we're going to do, we're going to leave this as false because it can be tricky. But what we can do here is we can also do this. So with sum, you can pass it a tuple. You can pass a tuple here to this, and you can say, all right, let's see what the min and the max and the mean and the median were, and maybe a count as well. All right. And now we've got some more statistics, all right, for those 2 years. So we've got a count of all the items of feed. So this will be probably the number of types of feed and the number of multiplied by the number of countries, right? Mm-hmm. That's your max, your min, your mean, your median, your min, right? So
what's neat here and interesting, coming from years in the traditional data architecture, data engineering kind of realm that I came from, is just how quick and easy it is to do this now using pandas and notebooks and data frames. This used to be, in order to get the same data, you used to have to write an application and parse that data, load it into a database, then run a bunch of queries, and it's all kind of statically typed, or you would do this with just a bunch of fancy SQL queries in a database. So it's just really neat to see how far we've come and how simple this is now.
Yeah, I think the data frame was just such a brilliant invention, really. And all it is a big flat table if you're thinking in database terms, but it just is so accessible. And really thanks to NumPy being able to do fantastic matrix manipulations, and then Pandas just mapping your non-numeric data into numbers so that NumPy can do that underneath. It's just so quick. Yeah, like you say, yeah. It's unbelievable what you can do. So let's just we'll simplify this back to just being a sum, right? And we can do our first little plot here, right? So this is really maybe that doesn't help us much. So we can change our plot. Let's just say I think it's kind equals bar. All right. So now we've got bar plots. So this is much more easy to look at than just a table, right?
Just out of curiosity, For fun, would it be easy enough to chart this by country?
Yeah. So all we could do is, instead of looking at it by element, right, we can say, what's the country field is called? Let's have a look.
Area.
It's called area. Yeah. So now with area, what's going to happen? But it's a good thing to see, and then see how we deal with it. Is that when you do it by area, you're going to end up, going to take a little bit of time, and you're going to end up with this type of plot, right? Okay, so our problem here is that we've got so much data, and you know, who's that big line? It's impossible to see, right? And who that. So what we can do is, before we do our plot, let's just do a sort values, and we'll say by equals, and we really want to do it by our, let's just do, we have to choose one of our years, so let's just do 2013, and sending equals false, and let's just do the head of that, and let's just look at our top 10 countries. Okay, so you see what I've done there? So I need a dot there. So first of all, so we've got, in fact, let's just show you the table first. So we'll build it up step by step. So there's our table, right? Which is a data frame. This is the index. So we've got our countries, we've got our 2012 and our 2013 values for food and feed. Or no, in fact, we've just got our values for food and feed combined for both, right? These are totals just by country. What we can do is we can do our sort values. By default, it sorts by ascending. So it would start with the smallest value first, right? But we want it to be largest country. So unsurprisingly, mainland China, biggest population, huge land mass, is the biggest exporter. And then you have India, then the United States, then Brazil, Russia. So you got your BRIC countries and America, right? So Brazil, Russia, India, China, kind of as you'd expect, these are huge exporters, and the United States. And then surprisingly, Nigeria. I wouldn't have guessed that.
Me neither.
Indonesia, Germany, Mexico. So these are all food exports. So interesting. Now, if we just look at the top 10, because we want to reduce our data, we're going to get this. And now we can plot that. And now we can see by year our each of those countries and how China kind of dominates it, and then you've got this exponential decay. So we could, you know, we could make that a bit, you know, maybe look at the top 20 countries, and you'll see it spread out. Now we can make this again. We'll use the same. We can make this plot a bit bigger. So I'll use the fig size equals 20, and maybe we'll just go with 10. So you can see it on the screen. So there we have our top 20 countries by export for 2012 and 2013, and we can see there's not a lot of difference between those 2 years. And obviously we could add more years in if we wanted to into here. So the other thing we might want to do, right, is we can add in columns here. And what columns let you do is add a further dimension to this. So I'm just going to get rid of that so that we can just look at what the table looks like. And let's have a look at this by element. All right. And what do we get? So now we get food and feed for each year by country. Okay. And we can again sort the values by 2013, but now this will actually break if we try and sort by that. And the reason is because we've got what's called a multi-index. Okay, so this is the big gotcha that hits here, right? You see up the top here, we've actually got, so we've got our index on the side area, but we also have kind of index on the top. So our columns now have 2 layers. They don't just have a single name for the column. They have year 2012, and they've got feed and food for year 2012 and 2013 feed and food. So if we want to sort, we now have to pass a tuple here, and we have to tell it that it's by year 2013, and let's just say food, right?
And then does one of those take precedence over the other? Like,
well, you have to put it in the order that they are. So you kind of work from your top down. So 2013 food, right? And then now we've got, and now we can look at our top 20, and let's plot that and see what that looks like. So it's a bit more of a confusing plot, isn't it? But so now what you've got is you've got feed and food and feed and food. So we've got food and feed for each of those years,
right?
And you can start to maybe see some patterns. Now, it's maybe not the best plot for looking at that, but we could just get rid of that and just have a look and see this. Make it a line plot, right? Now, line plot's also not the best thing, but you can also, but now you can see, you know, how food and feed kind of decay away for a particular country. Now, let's just say, rather than trying to look at all countries and looking, you know, we could do this and say, let's say df area equals, and what do we have? Let's just choose Italy. All right. So we've got our area is equal to Italy. So now we're not going to index on area. Let's index on element. And let's go by so what have we got? We've got element and item. Let's go by item. And then element. See what that looks like. Okay, so for Italy, right, these were the exports of feed and food for each of these years, alcoholic beverages, animal fats, and scrolling all the way down. So we can sort and see what the biggest ones were. Right, and let's just do a bar plot because I think it's kind of easier to look at. Right, so we can see how food and feed maybe have changed over the years, and we can see that meat is only exported for humans, isn't as animal feed. Vegetables are for both.
I was expecting to see a Chianti or something on there.
Yeah, I expect it's probably further down. Yeah, surprisingly. Well, alcoholic beverages, there they are.
Yeah.
Then I'd have expected that to be bigger than meat, but there you go. Vegetables, and vegetables other. Fruits, excluding wine. The wine's a fruit. There you go. One of your 5 a day.
Nice.
Wheat, cereals, and then milk. So, you know, milk and wheat and wheat obviously a big animal feed as well as human feed. So, and obviously we could, you know, let's have a look at Ireland and see, you know, maybe how Ireland compares. And let's just maybe have a look at, let's just look at 2013. And maybe let's do this, right? So this is a way of having multiple filters. So let's just say df area equals Italy. Okay, so now we've got Ireland and Italy. Let's, instead of looking at the element, let's look at the area. So now we can compare Ireland and Italy for those years. Oh, what happened there? I have left out something. here at 2013 food. Okay, so that's because we're not looking at it by that anymore. So item, interesting. What have I done wrong? So you got area equals Ireland and area equals Italy. Well, that can't happen, can it? Can only be one or the other. Can't be both, because there's no rows in our data frame where Ireland and Italy are both in them. So, okay. So you can use ands and ors where they make sense only, right? So now we have Ireland and Italy. Let's sort this by Italy, and something equals false. All right. So we can now look and say, all right, let's compare the two countries. Ireland does a lot less than Italy, right? For milk and butter. Surprisingly, you'd have maybe thought that Ireland was more top of mind when you think of butter, but Italy exports a lot more. Right. So you can see that with with that one pivot table format, we can look at the data in a lot of ways. The other things we can do, right, is our index can be item and element. So let's just do this. So we'll go item, element, and item. So we can have a list of things for our index. So we end up with a multi-index. So let's just have a look and see what that looks like. So now you have your data table shaping your data in this way. So now you have your elements. So it starts with food, and you have all of the different foods, and then scrolling down, feeds, because they come in the alphabet before food. So all the animal feeds, and then all of the human foods, and you compare each country like that. The other thing you can do is you can have multiple columns, right? So you could have area and not sure why we would have multiple columns. Let's just see one. Getting overcomplicated here, but item code. Well, I'll show you what you can do. The other thing you can do is, instead of having your, you can swap these around, right? So you can have your same data set, but now we're looking at Italy and Ireland on the rows, and the feeds and foods, and each of those categories in the columns. So you can see how you can reshape your data.
Right. And so, question for you, for people that are listening to this and watching this, who have no idea, this is the first time that they're seeing this. How did, other than years of experience, how did you learn a lot of this? And I know that's a very broad and vague question, but like, what might you have a tip for somebody that thinks, wow, this is amazing, I want to learn more, but where do I go? What do I do? You know what I mean?
Yeah, I do. So literally how I learned this was solving a specific problem, usually, right? So when you're exploring the data first, you kind of need to ask a few questions, right? So when you look at this, the list of these fields, you want to say, all right, well, what's in there? So that's why we kind of did those value counts, to see what was in there. What are these different categories? Then you might want to ask and say, well, which country's the biggest exporter, right? So then you're going to sort your values by the biggest exports in a particular year. Then you might want to ask, okay, what food is exported the most? So rather than looking at it by country, you might look at it by food. Then maybe you look at it by country, by food. So it's really what you're trying to do is answer a question, and that's what your pivot table helps you to do. Is to answer a question. And how then I figured out all of the the syntax and the logic behind it is really by starting with a simpler data set than what I was actually exploring. Quite often I would just create a really basic data set. Actually, I'll show you one here that I was, so this is one that I'm mentoring a student at the moment for coding nomads, and she's been working on a big data set, and sometimes it's easy just to create a simpler data set to work on, so that and what I often did, just to get my head around what actually is happening when you do certain manipulations. If you have a data set that's only got 20 items in it and 10 rows, it's very easy for you to see then, okay, this is how it works. Now I'll go and do it to my big data set and see if I get the same sort of answers. And also sometimes, you might be using the wrong statistic. Maybe sum is the wrong thing to use. Where are we here? So you might want to use something else. You might want to use a count, rather than the sum, or you might want to use, for example, let's just do this. We can look at item. We'll get rid of our columns, and if we do this, we're going to get, summing up the items just gives you a big long text, which doesn't really make sense. It's not probably what you want to do. Maybe a count might be more useful to you, so then you can count how many items there are that each of them are exporting. The other thing you can do is you can do an n unique, right, which should give us a different answer than count. This is a number of unique items, and it does. Okay, so it may be that this number you'd expect to be lower because a count of all the exports. We know that some items are exported as food and some items are exported as feed, whereas the number of uniques is irrespective of whether they're exported as food or feed. How many different types of produce are exported by each of these countries.
In that argument there, and unique, would that be in Pandas Docs, Data Frames Docs?
Yeah, Pandas Docs. Yeah, so
Pandas Docs.
yeah, so in fact, let's just go to the Pandas Docs because this is a useful skill.
Yeah, for sure.
Yeah. So Pandas Docs. Oh, let's just. So we go to Pandas, and here's the guide, the API reference in here. Okay, so if we go to series, you can find all of the stuff here. So let's just have a look at, I'll just do a search and we will do some. So you see there's cumulative sums, there's diffs, curds. So all of these different options, different things that you can do. Just do mean, yeah. Right, so you can do mean, median, min, mode, n largest, n smallest, percentage change. Quantile.
And was that, for instance, mean and median, min and max, were those the same ones that we used earlier?
Pretty much, yeah, exactly.
Yeah.
So all it is this is what you're doing is when you do a pivot table, you're creating a bunch of series, if you like. Each column is a series, and you can apply. So what's this ag function is doing is it's an aggregate function. It's applying this formula to that each of those value columns that you've given it, right? So whether that's counting, adding, getting them the max or min or median, it's just applying that to each of those series that you've created here with your values, right? And again, we can you could do Y 2011, right? So we can we'll see that in 2011 they had different numbers than in probably 2013. Okay, and we can add that a series of those. Let's just see the difference between 2000 and 2013. Maybe is more interesting, right? Italy is exporting less, and Ireland's exporting more in terms of types of produce. for some reason. And no doubt China is exporting a lot more, and the US are exporting a lot more than either of these two in terms of, you know, the types of products, because, you know, both of these countries have very, I suppose, small climate footprints, whereas, you know, China would have a huge climate footprint and you know, vastly different types of farming abilities, and different types of fish, for example. You know, so it's all sorts of stuff that'll be different in terms of the types of food that would grow in Ireland are different than what you grow in China. And
So,
the reason I picked this data set actually as one of the ones is because just with the whole COVID-19 and the lockdown, and, you know, I guess the whole global supply chain being put under stress, and I've often wondered why, you know, a country like Ireland, which has such a fantastic climate in terms of rain, and it's 40 shades of green, you can grow anything here. We have, you know, it's going to be daylight until, you know, probably after 10 o'clock tonight during the summer.
wow.
So we have like 16, 17 hours of daylight in the summer, up to 20, I think, in the longest day of the year, you know. So the summer has a lot of daylight, and it's where, you know, it's kind of always, it's never really dry. You know, a few 10 days in a row being dry is like a drought here. So yeah, so you can grow anything. And yet, you know, about a year ago, I was in the buying some produce, and I saw potatoes, which you'd really associate with Ireland, from New Zealand, you know, for sale. And I just astonished that
Right.
you could be importing from the other side of the planet, because you can't really get much further away from Ireland without leaving planet Earth than New Zealand.
Right.
You know, so why would we ship potatoes all the way from almost the exact opposite side of the planet to Ireland when we grow them here? You know, or we should be growing them here. So it's an interesting question as to, you know, where our food comes from, where it goes, and why do we export and import the foods that we do. And you'll often see, I expect, you know, the same foods on both lists of imports and exports, right? And it's because, you know, it's not like one entity doing the importing and the and exporting, you know. So there'll be businesses that are set up, and they'll be selling to, you know, wherever, and there's another business that needs that produce but decides to import it because it's cheaper rather than buy it locally. So, you know, all of those things, you know, globalism and commerce and agricultural industry, I think they're very interesting. And I guess that's probably a very long-winded answer to the question is, how do you go about finding out how to do this stuff? Ask a question and try and figure out how to answer it with the tools that are available to you. There's a great quote, actually. Arthur Ashe, he was a tennis player, I think back in the 70s, and he had a great quote from him, which is, you know, start where you are, use what you have, and do what you can, right? Which is really useful advice when you're doing data analysis, is that there's a lot of tools, but you probably don't need a huge amount of tools to actually get a really good feel of the data. A pivot table will get you probably 90% of where you need to go with data analysis, in terms of being able to reshape the data, explore it, and look at it. And, you know, particularly with Pandas here, you can slice and dice the data in almost any way using a pivot table. And then just by adding a dot plot at the end of your pivot table, you can visualize the data, and that's really, really useful, I think.
So then,
in fact, I could almost say that, you know, that's pretty much the core of what I wanted to express and explain today, is, you know, how to do this and why to do it.
yeah, it's really neat, and thank you for taking the time. So at work, let's say, when you're doing something like this at work, what would you do next? And you don't necessarily have to do it, but kind of where does this lead next? Okay,
so I'm going to do a kind of a false, you know, because I'm not sure if I can think of a good. Well, maybe I can, right? Let's create 2 pivot tables. So each, what a pivot table actually gives you back, right? This is actually a data frame, right? So let's just create a couple of really simple data frames off this. And let's join them together. Let's merge them, because that's the other thing that really is useful for looking at your data in different ways, right? Or joining 2 data sets together. So let's have a look and say, let's index on area. No, let's not. Let's index on item. Okay, so that's the type of food it is. And we won't care whether it's animal or whatever, and we'll get a value based on 2013. And we'll just get the sum. Right, so let's just have a look at that pivot table, and I've done something wrong. So values. All right, so okay, so these are all the different items that were exported in 2013 for all countries. Maybe we only want to look at, let's just say area. We're interested in a particular country, area equals, and I'll do Ireland again, just because I don't want to scroll up and see how to spell China, China mainland, or if it's got commas in it or what. Okay, so this is all the stuff that Ireland exported in 2013. So let's just, put this into a pivot table. So I'll call this DF2, right? And let's have a look at DF2. Okay, so now we've got a data frame called DF2, which is this. And let's just do a DF3 equals PD dot table, and we'll get the same data for 2000, say. Yeah. In fact, just see if I can make a copy of this. No, don't look. Do this. Okay, so we've now got 2 pivot tables with the item and the value in the years, right? So I'm going to join these 2, and this is, if I can get down to the next thing. So let's do a PD dot merge. And so what a merge does, it lets you join 2 data sets, and you just need to tell them what to join on. So I'll do this, right? So index, so we'll say left index equals true, right? Index equals true. And that'll give us back this data frame, which is basically Ireland's exports for 2013 and versus 2000 for all of these different types of food. Okay, so let's just call this DF4, right? And then let's create a field called DF4, and we'll just say ratio. Okay, and we'll say equals DF4 2013 divided by DF4 2000. Okay, and then let's have a look at that DF4. Oh. What did I do? Kira 2013. It's Y 2013 and Y 2000, sorry.
That's great. I like watching the
Yeah.
live debug process.
Yeah. Okay. So now what we have is we have a ratio which tells us, compared to, 2013, you know, how much more are we exporting? We're exporting slightly over, the same amount there. We're exporting less of apples and products. We're exporting more bananas, barley and products. Okay.
Will
Beans,
you
beer.
actually scroll up to the DF3 plot? Because I'm a little confused there, because see how on the wait, go down a little bit.
Yeah.
So, see how on this one it says 2013 and 2000. Oh, so okay, I just missed the decimal on 820. I was like, it looks like 800 in 2013 and 8,000 in 2000, but it's just from the resolution on my screen.
It's just got a decimal point. So what we can do, right, is so this ratio is kind of hard to read. So what I often do is you can just use, so round, you can round that off. Let's multiply it by 100 to give us a percent, and let's round it off to 2 decimal places, and let's have a look at that. So now you can see your percentage ratio. So that's 100%, that's 77,
Right.
it was none of those. So we can see, and then we could, we can always do a df4 dot sort values equals ratio. And now we can see what has changed the most. So there's obviously these infinite numbers, infinity, because it went 11 over 0 is infinity. Okay, so we started exporting some new stuff. This is 10,000, 1,000 times more, but then obviously there wasn't a huge amount anyway. So fermented beverages, oranges and mandarins. Okay, so there's so we can now see what's changed the most, and that's where this now you're starting to do data analysis, right?
Yeah, and
so
it's just even immediately you can start making it's it's really cliche, but better decisions with data. You see that kind of stuff in every, we have it in our copy like for our data science course and stuff. But you can immediately see now, for instance, if you scroll all the way to the bottom of this table, data frame, maybe the last so peas, like you might want to check in with your pea farmers.
Yeah, exactly. Yeah, what's going on there?
Yeah,
these might be imports. Actually, I've got a feeling. Well,
Oh, okay. Oh yeah, coconuts probably not.
Yeah, well, you never know though. You believe it or not, I went to a they've got all these old country houses that from when Ireland used to be an English colony. So the landed gentry had these huge, big houses, like what you'd see in Downton Abbey. And there's still quite a few of them around with their kitchen gardens, and some of them had hot houses and greenhouses and stuff like this. And I went to one, and they used to grow pineapples.
Huh.
Had hot water, in the hothouse, hot water, to keep the ground heated, and they were growing pineapples in Ireland.
Wow.
1800s. So you can grow anything here. I mean, today you can grow anything anywhere, really. Now that we've got all sorts of abilities to manipulate, light and water and heat.
Right.
That wasn't quite so easy before electricity. And now you can light things 24 hours a day with LEDs and grow stuff in a container. But so interesting that it's kind of interesting to see what where food goes, how it's changing over time. And so here's a really interesting data set. There's some other really interesting data sets in Kaggle. The other one that might be of interest to a lot of people if they're interested in food is the USDA, United States Department of Agriculture data set, which is all of the nutrient values for different foods. So you could maybe if there's an app opportunity there for someone who wants to create a data-driven app which looks at what you've eaten over a week, say, and calculates whether you're getting all the essential nutrients you need from your food,
Right.
and maybe what food you might want to add in next week to catch up. Should you add some oranges and or or plantains, or or eat less barley and products. So it's and swap it out for other stuff, so that we can, because food's so important. I just think it's kind of interesting as well that if you look at, if you were to consider choosing a product to sell, right, and you wanted a marketplace that was really dependent on your product and needed it, and it was growing in in need. As the world's population has grown, then the amount of food we need has grown. We all need it almost every day. Just about all of us want to eat 3 times a day. So the number of customers is growing, and the variety of stuff that the customer wants is growing. And yet, farmers in a lot of countries are the poorest people, yet they own the means of production. It's kind of the opposite of what you'd expect in a, if you were looking at it with fresh eyes. So, why is that? Maybe people are growing the wrong things. They're exporting them to the wrong places. The wrong subsidies are in place. There's all historical reasons maybe for things, but I think, what we grow and where we send it and where we buy it from is something we should probably all think about a bit more carefully. It, makes a big difference to the planet, to the, to the local economy, and to your own health.
Well said.
Yeah.
Very, very well said. So a couple follow-up questions on two. One, before we kind of leave this screen, is as a data scientist at work, kind of, and because even myself, I've never worked as a data scientist. What once, let's say that you're at your company, you're tasked with figuring out what seemed like, let's say that you're agricultural investment company, and are we in Italy, or I think we're in Ireland on this data?
This is Ireland.
Which investments should we be getting out of, and which investments should we be getting into, let's say, or like which imports, exports should we be getting out of, and which should we be getting into? And I know that right now the data is not perfect; it still blends the two data, the imports and exports, etc. But as a data scientist, will you then kind of will you go beyond the Jupyter notebooks and actually write this into any kind of code, or is this something that you'll check, or do you just kind of do this on the fly to inform the meetings with the investors? Kind of what's the kind of end result of your work look like? You know what I mean?
So I guess it depends on the question, right? So say the question was, all right, we're growing all of these foods. What should we be, what should we not be growing next year, and what should we? So then I'd want to look at the trends, right? I'd want to say, all right, in Ireland, this has been going down over the last 10 years. Why is that? And maybe then you need to look at your competitors, right? Which other countries are exporting those, and who are your customers? Who's importing those?
Mm-hmm.
And why is it going down? Maybe the prices are being driven down and the farmers are going out of business. Maybe another country is just able to make them, better quality because they're just closer to the customer, right? Or the customers started growing them themselves and saying, well, why are we importing potatoes from Ireland when we can grow them here in China? So it's, I think quite often the data really will inform your answer, but sometimes it just leads you to better questions, right?
Mm-hmm.
That are maybe outside this data set. And then you need more data. So I think I don't know where I heard it a few years ago, but there's never enough data. So when you have big data, and this is another important kind of thing that I've learned, right, is that aggregate data is often useless, or less than useless, because it can lead you to the wrong conclusions. I don't know if you've ever heard of something called Simpson's paradox.
I don't know that I have.
Yeah, so if you Google it, Wikipedia's got a great page on Simpson's paradox, and really there's been a couple of interesting case studies where if you look at for example, say, I think the one that they use as an example, it was admissions, females versus male admissions to some university in the States. And they said, look, women are being discriminated against because there's a lower number of them being accepted. But if you broke it down by course, then you actually saw that it looked like the exact opposite, that, men were being discriminated against because less of them were accepted to each of those individual courses. And it really was just boiled down to different choices that males and females tended to make for the types of courses, and then the number of people applying for those different courses as to what the individual acceptance rates were.
Mm-hmm.
Okay, so but aggregate data, when you slice it the wrong way, can tell you the complete wrong answer. So who was it? George Box, famous. I think it was George Box that said that if you torture the data, long enough, it'll tell you whatever you want to hear.
Yeah.
And that's the thing, is that we're all biased, right? We can't help but be biased. So the real trick with data analysis, I think, is to try and answer the question, but try and do it like a scientist. So this is where the scientist part of data science comes in, right? Is that when you design an experiment in science, what you are actually trying to do is you're trying to design an experiment which proves you wrong. Right. So when you look at your data, what you're trying to do is you're trying to find the data that shows you that your assumption is wrong.
Mm-hmm.
And if you cannot find that, no matter how hard you look, then there's a chance that your assumption is actually right. Okay. And the data's clean. Now, sometimes it really is obvious, right? Numbers are going up, sales are going up every year because, and it's because, you're spending more on advertising, or you've hired more salespeople, or, there's more people in the world, so there's more people eating this, meat, whatever it is that, there's some things that just have got nothing to do with anything else but the obvious answer. Coca-Cola, they used to have an ad called, Coca-Cola adds life. And if you look at every country in the world, as Coca-Cola sales have increased, so has life expectancy. But it's not because Coca-Cola itself adds life. It's because, as every country has become more industrialized and westernized and less third world, they have drink more Coca-Cola. And, Coca-Cola sees them as more of a marketplace because now they're not subsistence farmers or surviving by just catching fish in a dugout canoe anymore. They now have money. They now have money to buy Coca-Cola. Coca-Cola's sales are going to go up, but so is everything else, the standards of health, water, sanitation, more doctors and nurses, etc., and better, health, because presumably if there's Coca-Cola being imported, there's other things being imported too, so that are slightly more healthy.
That's a sneaky little ad there.
Yeah.
It's true. I mean, the data set is true. The more Coke,
exactly.
the longer they live. But
I think there's someone's got a website, for spurious correlations. Like cheese sales in Nebraska caused divorces in New York or something.
Right.
So it's very easy if you've got a big data set in particular to find spurious correlations, and the more, the bigger your data, the more likely you are to find, stuff that is absolutely not related to each other. Your p-value just tells you, p-value of 0.05 just tells you that 1 in 20 times, you're going to be wrong. When you've got a big data set, 1 in 20 times is probably too much, right?
Yeah.
When you're comparing thousands of things against a couple of other thousand things, that means you're going to be wrong thousands of times. So you need to be very careful. It has to make sense.
I like the way that you said it in the, and it's so simple, but it's normally where we come up with an opinion and then we do everything we can to support that opinion, right? We're in some kind of discussion or argument or whatever, but the scientific approach is to come up with that opinion or that assumption and then do everything you can to prove it wrong. It's a slight distinction with massive effect.
Yeah, no, it is. And, because we're all blind to our own bias, right? So it's to try and just, be aware of what I suppose be aware of our own ignorance, right? Because and every data set has got missing data. That's the other thing, right? No matter how good the data set is, even if you collected it yourself, you'll know what the missing data is likely to be. But if you're looking at someone else's data, and this data that we're looking at here has been already treated by someone as well, so it's probably as good as you're going to get, but it's still missing information in there, right? There's stuff we don't know, and we don't know what that missing information is. So you have to, whatever decisions you're making are always with partial data. And sometimes you don't know how partial that data is. Maybe you're only looking at 10%. Is that enough to make a decision? Well, it's probably enough to make, you have to make decisions, but you just have to know how much risk you're taking with those decisions, right? If someone's going to lay off 10 people based on the data analysis that you do, you really want to make sure that it's the right 10 people.
Right. So one other question I had was, you mentioned that here on Kaggle we can see other people's
yes, yeah, work. So if I go back here, right, leave that. It automatically saves your work, so you can just go straight back. But if you have a look here, up at the top of this data set, there's kernels. All right. So if I click on that, it'll show me a bunch of other people's kernels that they've done on this data set. So who makes it, right? So we can have a look at this. What are the top products produced around the globe? India's production story. So these are, so someone's gone and created a bunch of charts here, has asked different questions, production and price of wheat in India. So they're interested in India. And I think this is a great thing, is that you can go and you can look at other people's, explorations on that same data set and say, oh, interesting,
And so if you click the little code button there to the right, it'll actually show you the.
Yeah, you can see the code. So so let's just go and have a look at. So let's have a look at this one. Are we producing enough food? And where's the code button?
This looks like more of a report or something here.
Yeah. Okay, let's go back and we'll look at it. Go back to the one that we were looking at. Who makes it? Is it this one?
Yeah.
Yeah. So you can just look at the code that they use to generate that chart.
And that's a great way to learn right there.
Yeah, exactly. Looking at other people's code is really, really useful, and that's the beauty of Python, right? Because you can just look. You can look right into the library code for any of the libraries that you're using. So it's very cool. Accessible. It's very readable as well, Python code. I mean, if you look at this, it's kind of, it's telling you what that. Yeah, it's telling you the ggplot style. That's a data frame. They're doing a group by, which is the other thing people really need to learn how to use, group by.
Yeah.
Maybe another call.
Yeah.
They're doing an ag function, right? So just doing a count of each of these elements, and then they're sorting, again, ascending. So they're sorting by largest to smallest. They're just doing this, instead of doing a head, they're using colon 25. So they're getting the top 25 there, right? And then they're saying plot, setting the figure size. They're doing some subplots because they've got more than one. It's only one plot, yeah. It's a bar plot. They're setting the title, and then they're doing plt.show. Now you probably don't even need to use plt.show in here, but it's useful if you export this to a Python script and you want to run it anywhere outside of a notebook. You would want to have your plot.show, right?
Silly question here, but how, for the aesthetic in all of us, how did they get these fun colors, or is that just? So
that's the style.
Okay, cool.
Yeah, I think it just automatically just gives it, and there's lots of different options there. And okay, so this is using let's just go and see what data. Yeah, so they're using matplot and Seaborn. So Seaborn is a fantastic charting library.
Mhm.
It runs on top of Matplotlib, but it lets you do all of these nice, fancy, different looking, nice looking plots. And if you go to the Seaborn website, they've got tons of examples. Likewise with Matplotlib, there's tons and tons of examples. And Pandas uses a subset of Matplotlib with its dot plot. It's just very easy straight off the bat to create a plot without having to know all of the ins and outs of Matplotlib. But once you start using these and wanting to do fancier charts, I think Seaborn's a fantastic library.
Nice. Well, this has been really, really cool. Thank you so much again for just sharing your time with us and teaching us all this. It's incredibly intriguing, and I can only imagine for those of you who are watching this for the first time, maybe a bit confused about the syntax. I would highly recommend just coming here into Kaggle and finding some data set that you're interested in, and I'm sure there's all kinds of great data sets out there. If you're into astronomy, you could probably find some astronomy ones. If you're into health and wellness, climate, COVID-19, I'm sure there's fantastic.
There's dozens of COVID-19 ones. I thought I'd steer away from that for this talk. I thought it's probably
we did that because we actually had a course running. It was March, and we were in the middle of the course, and it was quite interesting. And there was some COVID-19 data coming. It might have been early April, and we started working on it, and we quickly decided not to because it was just really depressing. It was just these exponential charts in cases and mortalities and stuff, and we're like, let's come back to that.
And also I think the part of the problem with the COVID data is it's different from every country. It's very hard to compare stuff that's actually meaningful. And even if you look at a single country, over time, how they've done the measurements has changed, So, like the number of cases depends on the amount of testing and how valid the tests are. And, I don't think there's any one country that's only using one test. So, it's the quality of the data is not particularly great. Now, when you aggregate the data, again, aggregate data, you can make big, assumptions that are quite wrong. It's always interesting, I think, to look at creating a simulation as well to compare your analysis against. If you can.
So what do you mean by that?
So instead of using real data, use some data that follows. You can create data that has a normal distribution, right? Mm-hmm. And then you can do your analysis on that and say, all right, if I had two normal distributions that were just, that the mean is slightly different from each other, and I take a random sample from both, and I do this analysis, what do I actually see compared to my my real data sets that I think there's a difference between the two, right? And you can do that. The beauty of it is that you can do it 1,000 times between two, your two data sets where the underlying distribution because it's created data. And you can take a bunch of random samples of the same size as the data that you actually have in the real world and say, all right, 9 times out of 10, it's going to be hard for me to tell that there's any difference, even though there is a difference. And my data set could be one of those 9 times out of 10. I'm probably just not going to be able to tell the difference between these two data sets, with this type of data. So I think it can, again, it's like trying to prove yourself wrong. Because it's very easy to, with the statistics, out of the rule book, just say, oh yes, I've done this, and there's a p-value of this, therefore there's a difference between the two data sets. Sometimes, but not always. So it's, these things as well, you kind of come with experience. It's usually by making a mistake, and hopefully not a mistake that's going to, that's like the type of decisions that are having to be made about, how to work around COVID-19. It really is decisions being made with incomplete, partial data. Now we have very good data from past pandemics and epidemics, but it's still, it's always, it's unique in every case.
It's really interesting too, and and it's. I want to let you get back to your evening over there too, so I don't take all your time. This has been really great, but something that I've just been personally, like here in the U.S., obviously the COVID-19 numbers are just, very regrettably high, but the interesting thing about it is that having been here, we actually came back to the U.S. in early March as global airfare was shutting down and just kind of have been hunkering down, and we've seen the accessibility of the testing, right? It was non-existent for a while. We came back from Indonesia. We were traveling all over the world. We kind of flew right through the middle of the pandemic, and we sought out testing. Is there testing, and there was no testing, and kind of waited and waited. And in our experience here, there has been a direct correlation to the availability of testing and the number of cases, right?
Yeah.
So now just 100 yards down the street, 200 yards down the street, there's a community center that has no symptoms free testing. Like you don't have to have any symptoms. You can you have to make a reservation, but and so we're seeing these numbers still go up and up and up and up. And it's like, but it's interesting because here on the ground, it certainly feels like it's less and less and less in a way.
Yeah.
But the numbers are still going way up, and it's really, the numbers aren't telling the full story, right? The number now that we have more tests, we have more cases. There's still a lot that could, the U.S. could obviously be doing better to.
I think every country is struggling, right? Mm-hmm. Because it's very hard to test enough people quickly enough, often enough to catch it. It's a really, I we're really lucky in one case that it's not like the H1N1, whatever it was, the avian flu, which killed like 50% of people that got it, right?
Yeah, thank goodness.
But they knew they were sick straight away, right? You knew when you were contagious. More than half of the people, possibly up to 80% of people that get, COVID-19 show no symptoms, mm-hmm. right? And are spreading it whilst they're symptom-free. Now, 80% of those people are not going to have any symptoms either and spread it. But the trouble is that there's other people that are going to get really sick and die, because they're just susceptible, and we're only discovering what those things might be, because young people, obviously older people who are more frail and, have, health issues already are more susceptible. But some young people who seem healthy in other ways have ended up being very ill from it, and mm-hmm. we don't know why yet. So that's the trouble. There's a huge amount of data, and yet it's still not enough to make really good decisions. So
like you said, there's never enough data.
Yeah, never enough. And then again, you've got to slice and dice it. And once you start slicing and dice it, no matter how big it is, it gets smaller and smaller. Right. So yeah. So anyway, I think this too will pass. We will come out the other side of it, hopefully wiser, hopefully, with an ever decreasing amount of fatalities from now on. And we'll all, maybe the world will be, hopefully we'll learn a lot from this, in terms of how we behave towards each other, how we behave towards other countries, and how we value the people that are actually doing the really important work in society, because now we know who they are, right?
Exactly. Yeah. Well, Sal, I really appreciate your time again. This has been really interesting, and thank you also for the work that you've been doing, mentoring students with coding nomads. It's just been great. This is just wonderful all around, and this was really eye-opening to me and hopefully to others. And I look forward to chatting with you again soon. Is there anything else you'd like to say before we sign off?
No, I just want to say thanks a lot for for Coding Nomads. I think it's a brilliant platform. I think it's great. I think organizing the mentoring. I'm learning a lot. I'm getting a lot out of it.
Nice.
I hope that my mentee is getting as much out of it as I am.
Oh, I'm sure she is.
And I just think the whole idea of coding as a skill, as a thinking skill, I think it's really useful for everyone to have. And fair play to you for creating a platform, for spreading it, and for for creating this opportunity for so many people to share their skills and to acquire new skills. So thanks. Well done.
Thank you for that. I really appreciate it. Great.
Yeah.
Well, thank you,
Great
Sal.
talking to you, Ryan. Take care, and
have a nice night.
I'll hopefully see you again soon. You too. Take care. Enjoy your safe move.
Thank you.
Okay. Bye now.
Hey everyone, thanks for watching. If you enjoyed this video, please let us know by liking and subscribing. If there's another topic that you'd like to learn more about, leave us a comment. We would love to hear from you. And if you want to become a coding pro, visit our website at codingnomads.co. See you next time.